Hi, everybody. I wanted to do a little bit of review of the readings that are on this chapter, and I think I'll just go because I hope that you'll be reading them and taking notes on them before the midterm. I think it's a good way to review for the midterm. So I'll first start with chapter 3. So chapter 3 starts off by motivating regression analysis with our mask mandates and lockdown example. Then a little more motivation about causality, a little bit more about mask mandates, then a little bit of understanding of what the regression equation, our model is, what we mean by it. So if you're still not sure what this is all about, it's good to review these couple pages on page 51. Then we have a little bit of R for simulating some data to get a more concrete idea of what it is that we're doing. Then some of you may not have seen this, but here's the code to uh, display the scatter plot using ggplot with a nice scatter plot. So some of you should be copying this into your template to use in Econ 42. Won't be relevant for the midterm, but is definitely relevant for the lab. So there's our scatter plot. Then there's our idea about fitting the line by minimizing the sum of squared residuals, the method of ordinary least squares, where we estimate the intercept and the slope with the data that we have. We introduce the idea of the error term, right? The error that stands in for other factors and measurement error. And then sorry, a little bit of trouble with the Zoom here. There's our model explained. Then we have our data. Here's our sum of squared residuals. We choose beta 0 and beta 1 to minimize the sum of squared residuals. And we end up with our coefficients, beta 1 hat and beta 0 hat. And this is the formula, two formula that you should definitely memorize for the exam, not too hard. Then let's see, we have a little bit more on sum of squared residuals. Here's our calculus proof. I won't ask you this on the exam, but something that maybe I'll ask you on the final to take the derivative and prove that we get these coefficients. Then we can, what else can we do here? Then we generate the estimated error, the residual, right? So the residual is defined here, yi minus yi hat, yi minus beta 0 hat minus beta 1 hat for any given xi. So notice that we have a residual for each observation. Then we see how we do this in R. Let's see, here's our interpretation of the coefficients. This is in the simple case that our variable is continuous, not a dummy variable. So that's how we interpret it. And then we have our measure of goodness of fit, R squared, explained. And then we do some work in R to show it. We have our standard error of the regression explained. So this formula here, the standard error of the regression, that's the square root of sum of squared residuals divided by n minus 2, you should know. And then we go through examples of how to calculate. Many of you are using a different formula for how to calculate. I'm not sure, maybe because you saw it on a video or you had notes from some other class, but I think it's always really good to do it this way, to calculate it by hand this way. It's a good method to minimize the likelihood of making mistakes. So I encourage you to set up your calculations by doing it this way and review this part of chapter 3 in order to see how to do that. So there we go, some different calculations. And I would encourage you to work through all these examples and see how they work. Then we have our dummy variable as explanatory variable, how we interpret the dummy variable as the difference between being in category 1 and category 2. I do a lot of algebra here to prove with you that that is the case, but you don't have to memorize or review any of that. I won't ask you all this algebra here on the exam. So that's, I believe that's the end of chapter 3. Then we have chapter 4. Let me move things around here. So we have chapter 4, which is basically looking at the at how we make inferences based on our sample about the population. So we have our assumptions, and the assumptions that we have, right, are highlighted here, and those all should be reviewed. The causality, the linearity of our relationship, the Anscombe quartet, as it's sometimes called, these different patterns of data all having the same regression line, but obviously having very different patterns. That's something you should review and understand it. Then we have our key assumption about there's no confounders. That is, the other factors are not correlated with X and causing the outcome. And that situation, that condition holds automatically in the case of randomized control trials where the X variable is allocated randomly. Then we have our ID assumption. Then we have something that I think everybody understands at this point, which is how to conduct hypothesis tests about the about our estimated coefficients. If we think of them as random variables, we have the assumptions of homoscedasticity. I will not expect you to memorize these formula for the standard errors under homoscedasticity or heteroscedasticity, just to know that there are formula that we calculate and R will produce them for us. Then we have our t-stat and how we calculate the probability under the central limit theorem, which tells us that the t-stat follows a standard normal distribution, so we can calculate a p-value for it and use our convention to accept or reject. I think that's all pretty straightforward, but I encourage you to read it. I think it will be helpful to you. Section 4 here is the confidence interval, which is very straightforward. I haven't even gone over it in class because it's so straightforward, but you should know that this is how you do it and calculate it. And then we have the R code for calculating it. So that's pretty straightforward. And then finally, we have our multivariable regression model, which is just an extension of the other two. So not terribly different. Here's our new model with multiple X variables. We have how we think of these variables as our estimated coefficients as random coefficients. So we have the t statistic. How we interpret the coefficients are here, dummy variables and continuous coefficients. Let's see. Something we'll talk about in class tomorrow, how we standardize coefficients and how we talk about the magnitudes of coefficients is something that you should definitely review, reviewing, how we compare the magnitudes of coefficients. The measures of goodness of fit and the multiple regression model are slightly different. Here's the R square, which you should know, and the standard error of the regression. And then we have the same OLS assumptions, but we add now the assumption of no perfect multicollinearity. And then we have the how we do it in R. Here's a table of regression results. You should see how the language, the discussion here interprets the table of regression results. I think I'm not going to ask you about section 8 on the exam. Here is a section about interpreting coefficients. So this was on the lab that we did last week. So you should definitely take a read carefully through this about proportions and percents and how you interpret those coefficients. It's very confusing, it's tricky. You should take the time to understand the difference between a unit change and a percentage point change and a percent change. So we have a long discussion here that I think will be helpful. By the way, these chapters, you might, if you download them at the very beginning of the class, you might download them now. They're slightly different from what they were at the very beginning of class. And that's my 9 minutes, so I'll stop there and wish you good luck on the midterm.